6.1 Verifying Trig Identities. Your learning goal is that you will be able to prove and apply trigonometric identities. In this lesson, we're going to be verifying identities, and you're going to have to know these fundamental trig identities. So I put these in here so you can learn them. We have the reciprocal identities, the quotient identities, Pythagorean identities, and the even-odd identities. We have covered these in previous lessons, but we are going to be using these now to help us verify. Now, I do want to note that for these Pythagorean identities, you can change these around to make them equal whatever you want. So, for example, if you wanted to solve for cotangent squared, you would just subtract the 1 over. So you can manipulate these however you want so that it will help you to verify an identity. I created this slide to give you tips on how to verify identities. And in pink, it says that to verify an identity means to show that one side is simplified to be identical to the other side. And some of the tips that you can use is you're going to work with only one side of the equation, the more complicated side. You're going to apply the fundamental identities from the previous slide. And specific techniques to use, number one, rewrite the complicated side using sine and cosine. Factor out a GCF. Separate single fractions into two fractions. Combine fractions using least common denominator. So that means get the common denominator and you can combine them. And number 5 says to multiply the numerator and the denominator by a binomial factor. That means two terms that you actually see on the other side of the equation. I know it says that you're going to work with only one side of the equation, but sometimes you may have to work with both sides, and all you're doing is showing that they are equal. So we're not going to do a lot of these in the actual notes because the best way for you to learn how to do these identities or verifying is if you do them yourself. It's going to take practice. It's like a puzzle. You got to try to find different ways to make it work. So this first example, we're trying to show that one side equals the other. And when I said use the more complicated side, the left side seems more complicated than the right. So we're going to show that the left side equals the right. So I know that secant is the reciprocal of cosine. So I'm going to use a reciprocal identity. And then cotangent is a reciprocal of tangent. And I know that tangent is sine over cosine. Cotangent is cosine over sine. And see, what you're trying to do is manipulate this because remember now, our goal is to try to get to cosecant, which is the reciprocal of sine. So you want to try to make sure that you look at what you're trying to get to so you'll know what to use to get there. So the reason why we want to go this route is so that these can cancel. And then you're left with 1 over sine. And 1 over sine x is the same thing as cosecant. So once you've got the left side to look like the right, you verified it. Now the good thing about these is there's no right or wrong way to verify. Some of you all are going to figure out faster ways of getting there, and then some of us, it may take a little longer. Alright, let's try another one. And every problem is totally different. So okay. The left side here again looks like the more complicated side. And you have to always be logical about these and look and see what you see. And what I notice is both terms have a cosine x. So I'm going to factor out a cosine x. It's like you're doing backwards distributing. And you're left with 1 minus sine squared x. Okay. If you look at your fundamental identities, 1 minus sine squared is the same thing as cosine squared. And if you notice, remember now, this is what we're trying to get to. To make a 3, all we have to do is multiply these two together. And we will have cosine 3, because it's 2 here and 1 here. If you add them together, you get 3. And now, my left side looks like my right. Okay, for the third example, I'm going to use the left side again. And this is an example where you can split or change this single fraction into 2. So you put each part in the numerator over your denominator, like this. And the reason why I did that is because if you notice, what we are trying to verify has 2 parts. So I'm going to see if I can break these down into those 2 parts. So 1 plus 1 over cosine is secant, and sine over cosine is tangent. So now we verify the left side is equal to the right. Okay, we'll try one more. I'm going to use the left side again, only because the denominator has a more complicated denominator. So sometimes you have to look at what you're trying to verify. And if you notice, in the numerator there's a 1 minus cosine. So I'm going to multiply the top and bottom by that same binomial and see if that'll help me. Like this. And so in the numerator, I'm going to multiply that. Actually, I'm just going to write it as 1. And in the denominator, I'm going to FOIL. Let me write that. FOIL. So you do first, outer, inner, and the last two. When you write, it's like cosine squared x. You don't write cosine x squared. So if you notice, these two terms in the middle are going to cancel. And you're going to be left with still your numerator. And And on the bottom, you have 1 minus cosine squared x. Well, if you look at your fundamental identities, that's a Pythagorean identity. That's equal to sine squared x. And so I'm going to simplify this because I have 1 on top and 2 on the bottom. So that leaves me with 1 on the bottom. And look, I have verified my left side is equal to my right.